Hi students, so this is the theorem that I was talking about yesterday, like in the previous video. I told that, in the previous video that I'll be introducing a new theorem to you. So this is the particular theorem that I was actually talking about, okay? This is nothing but integration of f dash x divided by fx dx, which is equal to log of mod fx plus c, where fx is not equal to 0. Here we have to ensure two things only. The first thing is that fx has to be a positive function. That is why we have put a modulus sign here. And at the same time, we cannot include 0 for this function, as I have already told you before that if it is log of any negative number, or if it is log of 0, then this particular logarithmic function will be undefined. So in order to have a defined function, we have put a mod of x here, and we have also stated that fx cannot be equal to 0. I hope this is clear to you. This is a very simple theorem. It finds a direct application in the kind of questions that we will be dealing with, and even in like further when we get to move further in partial fractions and other stuffs like by parts and all, integration of by parts and all, there also we will see that we have a direct application, okay, of this particular theorem that I taught you. So it is actually very, very important, okay? If possible, mark it as very, very important, okay? So the first question is that integration of 1 plus cot x divided by x plus log sin x into dx. Now the first thing for you will be to notice that whether the integration that is given to you is in this particular format of f dash x by fx or not. So you can easily understand, like just with one view only, you can state that the denominator is actually fx here. And how can you say that? Because after doing f dash x of this function, you get this function only. Let me tell you how. Our function fx here is nothing but x plus log of sine x, right? And when we differentiate this particular function, we get it as 1 plus. Tell me, what is the differentiation of this particular function log sine x? First, we will do the differentiation of log function. So, which means if I differentiate this log function, I'll get 1 by sine x. And then after differentiating log, we will differentiate this sine function, okay? And what is it? It is nothing but, sine x is nothing but cos x, right? So this is nothing but, this is 1 plus cos x by sin x is cot x. As simple as that, okay? So this is the particular differentiation of the fx function given to us here. So which means that this particular given integration is in the form of f dash x by fx. So we can easily apply the particular formula here. So what we will do here, the formula is, the theorem says log of fx. So what is log of fx? This is actually a pretty direct problem. Just to introduce you to this particular theorem, I have given this to solve. So log of x plus log sine x. Why? Because log of fx is plus c is the formula for this particular theorem. That is why we have directly put it here, okay? And so this is the answer for this question. I hope it is very clear to you, okay? I explained everything here. Now we will solve a couple of problems very quick, so that you get a rough idea of what I'm talking about, in case you did not understand what I said so far. So now we will deal with, say, our second question, which is integration of 1 minus sine 2x divided by x plus cos square x dx, okay? So now tell me, now how should we approach? Do you think that f of x will be x plus cos square x here? Well, first let's check it if the f dash x of this function actually is the numerator or not. So if we do that, we will get 1, and here what we will get, cos square x. How do we differentiate such a function of cos square x? First we do 2 cos x, okay, and then first the differentiation of the power, and then finally differentiating the trigonometric function itself, which is cos x, and it is nothing but minus sin x, okay. So we get minus 2 sin x cos x, right? And so tell me, what's the formula of 2 sin x cos x? Nothing but minus sin 2x. So we will be getting 1 minus sin 2x here, right? So if we get 1 minus sin 2x here, what does that mean? We are getting this f dash x by fx format, right? We are getting the f dash x by fx format, and the integration of f dash x by fx format is very clear to us, right? So we will simply write this as log of mod x plus cos square x, right, plus c, okay. So this was the thing, and now we will be doing a few more number of problems, okay, in order to run our hand on these a bit. So next what we have here is x minus 2, 2x square minus 8x plus 5. Alright, and the integration of this particular problem. How will we solve this problem? Can we consider this denominator as f of x? Let's see. If we consider the denominator as f of x, then do we get the numerator as our f dash x? Let's see if we do. So f dash x is nothing but 4x minus 8, right? But unfortunately, in the numerator we have x minus 2. So which means if I take 4 common here, then we get x minus 2 here. We have an extra 4 multiplied. So what we will be doing? In the last theorem, remember how we manipulated every question? I hope you remember how we manipulated every question when we were not getting the exact format for our f dash x, okay. So in that case, we did some manipulations, okay. Here also we will be doing the same without changing the exact format of the question given to us. So what we can do here, we can simply multiply and divide by 4 in numerator and denominator, then only we will get this thing, right or not? Now it is in the perfect format of f dash x by fx. Now our simple job will be to just put the particular formula that we know. We know that log of fx, which is nothing but 2x square minus 8x plus 5 plus c. I was missing out on a 1 by 4 as well, okay. Same thing, just a bit of easy mathematical manipulation that made us reach into this one line answer, okay. Now we will be doing 2 more easy problems, okay. Our next problem will be say let's take cosec square x divided by 2 plus 3 cot x. All right, how do we solve it? Can we say that the denominator is fx and numerator is f dash x? Now I am telling this directly, okay. We have done a lot of problems before, so I hope now you are better off with the thing. So let me now explain it a bit. So this is integration of cosec square x by 2 plus 3 cot x dx. So if the denominator is fx, then what we get as the f dash x? If fx is the denominator, then f dash x will be what? 2 is a constant, so this will become 0, plus 3 cot x. What is the differentiation for 3 cot x? It is nothing but minus 3 cosec square x, right? In the differentiation of cot x is nothing but minus cosec square x. So in that case, what we will be doing, we are getting a minus 3 extra, right? So as I told you, when we come to such an issue where we get something extra, we simply multiply and divide it. Okay, so we will be dividing and multiplying by minus so that we can get the f dash x by fx format very easily. I hope that this problem does not require any further explanation as of now. Okay, I have explained everything in this problem. This was a very straightforward problem. Okay, still I explained in order to ensure that you don't have any confusion. Okay, one more problem which falls in the easy category. So now the next problem is maybe say x minus 1 divided by x into x minus log x dx. All right, so this is x minus 1. Okay, this is x minus 1. So this one is also very easy, but you might need a bit of manipulation because you see an x here which makes it a bit complicated. Okay, else others are fine. So what we will be doing here is we will be simply writing it like this. Now why did I write it like this? So that we can easily get a known format. We will do a bit more simplification here. Okay, we will do a bit more simplification here. So we will come to this finally. Now why did I choose to put x like this? If you go from this form to this form, you will get this only. Okay, x minus 1 by x, if you write it like this, this is same as writing x minus 1 by x like this. Okay, so I've made no changes actually, just put it in the denominator the same way. Okay, putting x here doesn't change our original format. All right, so why did I do all these things? Just to ensure that we get an f dash x by fx format. Okay, now in case you don't understand why, so if let's say I take this as f of x, let's say I take this particular denominator as f of x. Okay, so if f of x is x minus log of x, then what will I get as f dash x? Won't I be getting this? This is why I decided to put the entire form of the question in this way without changing the original question that was given to us, and yet helping us find a perfect solution to our problem. Now as this comes under this format, right? Now this comes under this format directly. So what will be the final answer then? It will be nothing but log of mod x minus log x plus c. I hope this is clear to you. I solved like about 5 problems, I think. Okay, yeah, 5 problems I solved in order to ensure that you get a rough idea of this formula. I'll be solving 3 more problems maybe. Okay, 3 more problems. That will be a bit of medium level problem. Okay, not tough. A medium level problem in the sense that you might have to make some rough manipulation here, take things over there and here. That is why. Okay, so I hope you understood all the 5 problems and most importantly the theorem that was introduced. And always remember that you have to put the mod sign here. Okay, if you do not put the mod sign, then your entire question, like the entire solution that you provided in your exam or in your answer sheet, whatever, will be marked as wrong, because log of, in case the function that you have taken comes out to be negative, you know, which will happen in many cases. So what will happen is your entire answer will go wrong, because log is not defined for negative function and also for 0. Okay, so putting this mod sign is very, very important. I hope you got whatever has been taught in this video. Now we have to move forward for our next video. Till then, all the best.